Hello everyone. Today I will present our work called Unsupervised Graphic Layout Grouping with Transformers. Layout grouping aims to organize the elements in a graphic design into perceptual groups, forming a hierarchical structure for effective message delivery. For example, elements in the slide can be grouped at two different levels. A. The text box along with the diagram can be assigned into one large group. Or B. Besides the title box, the text box on the left and the complicated diagrams composed of many elements can be assigned into two separate groups. By parsing the group structure, we can enable many potential applications in graphic design intelligence, such as graphic design understanding and summarizing, content extraction and generation, graphic design beautification. In this paper, we propose a highly performant approach for graphic layout grouping using the transformer architecture. Specifically, given a list of elements, our model progressively combines elements into groups with L grouping layers. We designed two kinds of tokens for token element tokens. Each graphic layout is represented as a sequence of element tokens E. And for group tokens, groups with different granularity is represented as group tokens G. Before the first layer there is an element encoder. We represent each element with properties like type, position in the embedding space by concatenating the property embeddings, and use element encoder to convert them to corresponding element tokens. Then, for each grouping layers, each layer L contains a transformer-based block with learnable group tokens GL. Element tokens are concatenated with the group tokens into the self-attention for contextual representation learning. We set the two learning objectives, set prediction and anchor prediction, to assign elements to corresponding groups. On top is an element to group cross-attention which partitions elements into groups and obtains the new element tokens for the next layer. Finally, we get the hierarchical grouping, two layers in this example, for this PowerPoint. Also, we propose an approach to train the network in an unsupervised way. Firstly, we introduce a heuristic algorithm that utilizes the Gestalt principles to generate pseudo-labels. Although the pseudo-labels may be incorrect in challenging cases, we find that they suffice to train a reasonable initial model. Then we use bootstrapping to refine noisy labels and retrain the model. After each training epoch, we evaluate the model's predictions. High-confidence predictions replace the original pseudo-labels with a confidence threshold. This approach proves effective for complex layouts and leverages large-scale and labeled data for unsupervised training. We collected a large-scale dataset of public presentation slides in the PPTX format for training our model. After filtered, our final training dataset consists of 369,347 slides. For evaluation, we created a human-labeled dataset consisting of 79 slides. For evaluating at different levels of stringency, we propose two metrics ACC, soft, and ACC, strict, to evaluate the system performance. Besides, we conduct human evaluation to see how people rate the grouping outputs. While being compared, our approach outperforms the others. Here, I'll show some visualization results. Thanks you for watching.